Welcome back to the deep dive. If you're anywhere near supply chain, e-commerce, or, well, any kind of logistics, you know the game has completely changed.
It's not just about seasonal picks anymore. It's a constant state of rapid demand.
Exactly. You're being asked to handle more SKUs, offer that free 2-day shipping, and basically teleport products right into a customer's hands.
And that level of volatility, it just means that the logistics systems that worked, say, 5 or 10 years ago, they're now, frankly, obsolete. They just don't have the agility.
Which is why today, we're going deep on the two technologies that are making this shift happen. We're creating the smart warehouse of tomorrow.
We're talking about autonomous mobile robots, or AMRs.
And the AI layer that coordinates them, swarm intelligence. Our mission here is to give you a really tactical shortcut to understanding how these two things don't just automate tasks, they fundamentally change how things move.
And to do that, we have to define the players. So first up is the AMR. I think when most people picture a robot in a warehouse, they're thinking of the older tech.
The AGV,
Yeah.
automated guided vehicles,
Right.
the classic. And they're fine for, high volume, repetitive jobs, but they are completely rigid. They're on a track and they stay on that track.
And if something gets in the way, they just stop.
They just stop. They wait for a human to come and fix it.
Yeah.
They are literally bound to a fixed path.
And that immobility is the critical flaw in today's environment. AMRs are completely different. They use sophisticated sensing LiDAR, cameras, all of it, plus onboard intelligence.
It's dynamic navigation.
It's dynamic navigation. Think of it like a smart self-driving car versus, say, a train on a rail.
I like that. So instead of a painted line on the floor, the AMR is constantly building and updating a map of its own environment.
Exactly. So they adapt to changing layouts, they can dodge a dropped pallet or a person walking by, and they reroute instantly, in real time.
And that's the core benefit right there, that dynamic navigation. You don't have to shut down a whole part of the warehouse just for a robot's path. Okay, so let's dig a bit deeper into the practical side of things. Beyond just flexible movement, if you're putting down serious capital for these, what advantage are you actually buying?
Well, you're buying two things: task variety and data optimization. AMRs can do so much more than just point-to-point transport. They can handle picking, sorting, inventory,
And replenishment.
and replenishment. But even more importantly, they are constantly collecting data, real-time data about their own performance, their surroundings.
So they're learning.
They're actively trying to improve their own routes and cut down idle time with every single trip, and that directly helps you hit higher throughput.
And our sources really highlight how this helps the human element, too. The really heavy, repetitive, high-risk tasks.
These are things that cause injuries.
Exactly. The fatigue, the strain, that can all shift to these machines, which is just a huge step for safety and, well, for human resource allocation.
It is. The AMR is the perfect asset for e-commerce surges. But an AMR, no matter how smart, is still just one unit. The real magic, the real leap, happens when you coordinate them.
Right. And that brings us to the next level, coordinating the swarm. So if AMRs are your individual star athletes,
Then swarm intelligence is the playbook. It's the strategy that turns them into a championship team, where everyone knows what everyone else is doing all the time.
it's like something out of nature, isn't it?
It is. It mimics nature. Think about ant colonies or beehives. You have thousands of individuals, each one following very simple local rules, but together they achieve these incredibly complex outcomes.
So in logistics, that means lots of robots working together, communicating constantly.
And cooperating. That's the key, to do things way more efficiently than they ever could alone.
And the architecture is decentralized. That's a huge point. You don't have one giant, slow central controller trying to micromanage everything.
That decentralization is absolutely essential. It minimizes latency and it maximizes resilience. The robots share information locally and they adapt as a group.
And that's where something like Edge AI comes in.
That's where it's critical for dynamic task and road allocation. If a robot gets held up or a new rush order lands, the collective decides which available robot is in the best position to handle it.
So you're basically eliminating bottlenecks before they can even form.
Proactively, yes.
And that structure, that swarm, it must have a massive advantage when it comes to resilience. I mean, it's not like a server failing and a whole site goes down.
Not at all. If one robot in that swarm goes offline, what happens?
The others just pick up the slack.
The rest of the fleet just reroutes and reallocates that unit's tasks seamlessly. The system is inherently robust, and it's scalable.
Which lets you have these incredibly high-density workflows.
You're optimizing every single square inch. Many small, fast robots moving in these tight, fluid grids. It's a game changer for using your floor space, both vertically and horizontally.
Okay, let's paint a picture for everyone listening. Forget the old image of a big, heavy machine. Picture hundreds of these small, low-profile AMRs, almost like smart platforms on wheels.
All coordinating to bring shelves of items directly to a person who's packing the boxes.
Exactly. The swarm is handling all that internal movement, constantly finding shorter paths, speeding up the cycle times based on whatever the priority is right now.
But this requires a pretty sophisticated technical backbone to work. The sources are really clear on the need for what they call sensor fusion.
Okay, what does sensor fusion achieve in this specific context?
It's about combining data from multiple sensors, so
Yeah.
LiDAR, cameras, odometers, to get a much clearer, more reliable picture of the environment than any one sensor could ever give you.
It's essential when you have hundreds of robots operating just inches from each other and from people.
Without it, the collision risk would be way too high. It's enhanced perception for enhanced safety.
And you mentioned edge AI earlier. That's about speed, right?
Yeah.
Making decisions on the spot.
Absolutely. Edge AI lets those decisions happen instantly on the robot itself without sending every bit of data to the cloud and back. When you have hundreds of robots making thousands of decisions a minute, that near zero latency is the difference between a smooth operation and total gridlock.
So that transition from one smart machine to a coordinated swarm, that really brings us to the heart of this deep dive, the synergy. When you combine AMRs and swarm intelligence, you unlock five very specific, powerful benefits.
These are the 5 reasons the investment actually pays off.
Okay, number one, enhanced speed and responsiveness. The fleet organizes itself. It adapts in real time to a surge in demand.
So instead of someone having to rerun a master schedule, the AI just instantly finds the most efficient route for every single new task. It slashes your latency.
If you're managing fulfillment on Black Friday, that is non-negotiable.
Absolutely. Number 2, space optimization and cost saving. This is a huge tactical win.
Because you don't need those big fixed conveyor systems or wide aisles for forklifts anymore.
Exactly. The AMRs thrive in dense environments. You're effectively ripping out all that rigid infrastructure that eats up so much space.
So if you manage a distribution center, this means you can either fit way more in your current building or maybe even move to a smaller, cheaper one and keep the same throughput.
Precisely. You're shifting capital from inflexible buildings to flexible modular robots.
Let's talk accuracy. Benefit number 3, improved accuracy and fewer errors. Manual picking is, well, it's prone to error.
Which leads to very expensive returns and rework.
But when the task is automated by coordinated robots that are all aware of each other, making sure the right thing goes to the right place.
You see a dramatic drop in those error rates, and the sources point out that minimizing errors is one of the fastest ways to see your ROI. A returned item can cost 4 or 5 times the original shipping cost to reprocess.
Benefit 4 is a big one, flexibility and scalability. Markets are volatile. You have to be able to scale up or down fast.
And AMRs are modular. The swarm control lets you dynamically allocate tasks, so if a 3-month seasonal peak is coming,
You just lease 50 more robots, plug them into the system overnight, and they're immediately part of the team, optimizing everything.
it makes your logistics system truly future-proof.
And finally, number 5, workforce evolution. We touched on this, but it's really a strategic imperative for HR.
The swarm handles the strenuous, monotonous stuff. Humans move up to higher value roles: supervision, exception handling, data analysis,
Managing the system itself, it elevates the whole workforce.
and it's critical for retention. People are more likely to stay in jobs that offer some kind of development and engagement, not just pure physical labor.
It's clear the benefits are massive, but, implementing a system this complex isn't simple. Let's take a balanced look. What are the big hurdles an organization has to navigate to get this right?
Okay, we have to start with just the complexity of integration. You are simultaneously integrating multiple complex systems navigation, fleet management software, that edge AI control layer, and of course, safety systems.
And trying to mesh all of that with your existing, maybe legacy warehouse infrastructure.
Exactly. The challenge of keeping your operations running while you're basically doing a nervous system transplant, it's immense. Disruption management is a huge project in itself.
What an afterthought.
Not at all. And paramount among all these hurdles is safety, especially where robots and humans are constantly interacting. The source material is very specific here, mentioning the need for advanced methods like control barrier functions.
That sounds pretty technical. What is a control barrier function and why is it so essential?
It's basically a mathematical guarantee. It ensures the robot will not leave a predefined safe zone or violate a safety rule no matter what's happening. Think of it as an unbreakable, immediate safety override.
So if a person steps out unexpectedly,
The control barrier function guarantees the robot will slow, stop, or move away to maintain a safe distance. Safety always comes before finishing the task. It's a non-negotiable insurance policy against collision.
that makes perfect sense. Now let's talk money. The initial capital outlay for the robots, the software, the infrastructure, it's substantial.
It absolutely is. And organizations have to meticulously calculate that return on investment. It can't just be about reduced labor costs.
You have to quantify all the benefits we just talked about.
Yes, the increased throughput, the value of fewer errors, the gains from space optimization, the better service levels you can offer. Without that holistic view, the upfront cost can look too high.
And beyond the balance sheet, maybe the most underestimated hurdle is the human and organizational one. It's not just about retraining, is it? It's about culture.
This is arguably the biggest challenge of all. Your workforce skills change dramatically. You need people who can maintain robots and manage fleet software, not just drive a forklift. But the real strategic challenge is alignment.
What do you mean by alignment?
I mean the organizational culture, the management, the physical layout of the warehouse. It all has to be designed around the robots. So many companies make the mistake of buying the robots and then just trying to fit them into their old manual workflow.
And it doesn't work.
To get the full benefit, the robots have to define the flow. It means re-engineering your processes from the ground up. If you don't commit to that, you will never see the full ROI.
So the old system adapts to the robots, not the other way around.
That's the imperative. And finally, we have to mention data and cybersecurity. These fleets generate just massive amounts of operational data. The frameworks have to be robust, but also extremely secure.
A hacked robot fleet could grind the entire facility to a halt.
Exactly. Redundancy and cybersecurity are not optional extras, they are operational non-negotiables.
It's a complex picture, for sure. It demands total commitment. But the momentum is undeniable. So let's look ahead. Based on these trends, what are the key predictions for, say, the next 3 to 5 years?
I think we're going to see the barriers to entry just plummet. And that's happening in two ways. First, more standardization of the AMR platforms and the swarm software, less need for costly custom work.
And the second way, which is a huge game changer for smaller companies, the rise of robot as a service, or RIS models.
RIS is completely transformative. It lets companies adopt this tech on an operational expenditure basis. You pay per use or per month without buying the whole fleet.
It just opens the door for mid-sized logistics providers instantly.
We also see AI getting deeply integrated across the whole supply chain, way beyond just the warehouse floor.
So AI is doing demand forecasting.
And those forecasts translate directly through the swarm software into dynamic instructions on the warehouse floor. It connects strategic planning to physical execution seamlessly.
And finally, that hybrid human-robot workflow you mentioned. That's becoming the standard, not a theory.
It is. Robots do the tedious internal transport. Humans do the high-value exception handling. And we shouldn't overlook the sustainability gains here either. Optimized routes, energy-efficient fleets, that lowers your energy consumption, which is becoming a key factor for ESG reporting.
So, to wrap up our deep dive, the combination of AMRs and swarm intelligence isn't some marginal tweak. It unlocks real agility, responsiveness, accuracy, and true scalability in logistics. The smart warehouse isn't a concept anymore. It's here, and it's a living, coordinated organism.
And that leads to the final thought we want to leave you with. Understanding this technology as well, it's just the first step. Adopting these tools strategically isn't about just adding some robots to a line item.
It's a commitment.
It is. It's a commitment to re-engineer your processes, redefine your workforce's roles, and completely overhaul your systems to truly exploit the full potential of this next generation of smart warehousing.
So if you work in operations, start by looking at your current internal transport latency and ask a simple question. Are our systems built to adapt, or are they built to break under pressure?
That's the strategic question that will dictate success.